Good day, everyone. Welcome to class. My name is Dr. Nkemjika Obioha, and I am your chemistry teacher for today. Today, we'll be talking about chemical equation. To show you what happens in a chemical reaction, we need to first of all know what a chemical equation is. Now, for us to dabble into chemical equations, we need to talk about the terms, the terminologies in chemical equation. While talking about chemical equation, you must have heard me talk about chemical reaction. Now, what is chemical reaction? A chemical reaction is the process in which one or two substances come together to form new substances. So one or two substances, they come together to form new substances. Let me give you an instance. You can say the formation of water is as a result of hydrogen coming together with oxygen. So let's say hydrogen plus oxygen, this gives us water. This is a chemical reaction because two elements, hydrogen and oxygen, came together to form a substance, which is water. Are you getting me? So the way two elements like hydrogen and oxygen comes together to form a substance called water is a chemical reaction. Now, we're talking about terms. Another terminology you need to know about is what we call the reactant and the product. The reactant and the product. The two elements that come together to form another substance or a solution, they are called the reactants. If you look at what is written on the board, you will see that we have the hydrogen and we have the oxygen coming together to form something which is water. Now, this hydrogen and oxygen is called the reactants. And what they formed is called the product. So this shows you that hydrogen and oxygen in this particular example are the reactants, whereas water is the product. Are you getting me? Now, in a typical chemical reactions, there are symbols. We don't have equals here, we have an arrow. We have different types of arrow. It could be one arrow or two arrows. When it is one arrow, these arrows are showing the direction of the reaction, where the reaction is headed to. So when it is one arrow like this, it means the reaction is complete. So it is forming one product. It is not going back to the reactant. Now, if it is two arrows like this, it means it's a reversible reaction. After this class, we'll be talking about the different types of chemical reactions. So you will elaborate on what I mean by reversible reaction. But just know that when these two arrows are in a chemical reaction, that type of reaction is called a reversible reaction. Are you understanding me? Good. So this is very important. Now let's go into what is a chemical equation. So a chemical equation is a symbolical representation of a chemical reaction using symbols to indicate a chemical reaction. Using symbols. Now, what is on the board here is a chemical reaction. Now, when this chemical reaction is written using symbols, then it is a chemical equation. Now, let me give you an instance. What is written on the board is hydrogen. And we know that hydrogen, the symbol of hydrogen is H on the periodic table. You can remember when we learned that on the periodic table. Now, the symbol of oxygen is O. You remember, right? Now, when hydrogen and oxygen come together, they form water, which is H2O. I hope you understand it. Now, there is something that you need to note. There are atoms that are called diatoms. I know we learned about atoms, right? Now, there are elements that are diatoms. Example of such elements are hydrogen and oxygen. They are diatoms because they come in pairs. They cannot stand on its own. So hydrogen cannot stand on its own. So hydrogen is 2. Oxygen cannot stand on its own. So oxygen is 2. Because they are diatoms. Now, hydrogen plus oxygen gives us H2O. Now, if you look at this, this is a typical example of a chemical reaction. Now, there's something you need to note about a chemical reaction. We've talked about the arrow, which means a direction with which the reaction is headed to. Now, this plus here, it holds either the products or the reaction, or the reactant, sorry. So when you have more than one compound or more than one element at the reactant side, you put a plus. When you have more than one element or compound at the product side, you put a plus. Okay? Now, let's look at it. In balancing chemical equation, we have reactions that are balanced and we have reactions that are not balanced. Now, how do we know when a chemical equation is balanced? If you look at this equation here, you will see hydrogen. Hydrogen is 2 and oxygen is 2 at the reactant side. Hope you remember when I said the reactant and the product side. The reactants are the things forming together, coming together to form a product, right? Beautiful. So if you look at the product side, you will see that we have hydrogen 2 and we have oxygen 1. Now, what it means by being balanced and unbalanced, a chemical equation being balanced and unbalanced, is that the number of elements at the reactant side are not the same with the number of elements at the product side. So when they are not the same, the equation is unbalanced. But when the number of elements at the reactant side is the same with the number of elements at the product side, then it is balanced. Do you understand? So if you look at this equation on the board, is the equation balanced? The answer is as good as mine. It is not balanced. Because at the reactant side, hydrogen is 2, oxygen is 2. Whereas at the product side, hydrogen is 2, oxygen is 1. Now, we will look at how to balance a chemical reaction. There are rules in balancing chemical reaction. Rules of balancing chemical reaction. That is what we are going to be looking at. 1. I said rules of balancing chemical equations. 1 is that you need to, when you are balancing a chemical equation, you only balance elements at their left hand side. So you don't balance at the right hand side of an element or a compound. What do I mean by that? In this equation above, you will see hydrogen here. Sorry, oxygen here. There is 2 here. This side is the right-hand side of this particular element, right? Then you will see this side that is empty is the left-hand side. Now you don't balance by writing a number here. You write the number here. If you now say and add 1 here and now write 3 here, oxygen becomes a different element altogether. If you come here and write 2 in water, this is no longer water. It becomes a different element. Do you understand this rule? So you balance here in front. So let's put it that way. You balance in front of the element or in front of the compound. That is one rule. Another rule is that you don't use half. You don't put half. Maybe when you're balancing, you said, okay, let me balance with half. No, because there is no element that is half. It's a whole number. So 2 is that you only balance using whole numbers. So 2, so the second one, you only balance using whole numbers. Now, in balancing chemical equation, something worthy of note is the law of conservation of mass. Now, law of conservation of mass, it states that matter can neither be created nor destroyed. So, matter can neither be created nor destroyed. So, what this means is that the mass of the reactant must be equal to the mass of the product. So, for you to know a chemical reaction that is balanced, it must obey the law of conservation of mass. So what this means is that matter can neither be created nor destroyed. So it means that the left-hand side must be equal to the right-hand side. So that being said, let's dive into balancing chemical equation. Let's start with the example on the board. Now with the example on the board, we already have hydrogen, 2 molecules of hydrogen plus 2 molecules of oxygen to give us water. Now, we said hydrogen is 2, oxygen is 1. Sorry, oxygen is 2 at the reactant side. Now, hydrogen is 2 at the product side, and oxygen is 1 at the reactant side. Now, looking at it, you will see that oxygen here is 1, oxygen is 2. So let's balance oxygen here. We'll put 2 in front of water. If you put 2 in front of water, oxygen becomes 2. So oxygen is 2 at the product side, oxygen is 2 at the reactant side. So oxygen is now balanced. Alright, so let's continue. If you look at this, you will see that the equation is not also balanced because hydrogen at the product side is now 4. 2 times 2 is 4. And at the reactant side, hydrogen is still 2. So what do you multiply by 2 to make it 4? 2, right? So add 2. So hydrogen here becomes 4. So hydrogen is 4 at the reactant side. Hydrogen is 4 at the product side. Oxygen is 2 at the reactant side. Oxygen is 2 at the product side. So this equation is now balanced. Now let's look at the second example. This time around, this example will be from past question. So I got this particular question from IGCSE past question. So there is something I forgot to mention. In a chemical equation, we always write symbols like this that you're seeing here. We write symbols like this, and like this. It is only telling you the states. You know, when we talked about the states of matter, we said matter can be liquid, solid, or gas. Matter can also be aqueous. Now, when you see a chemical reaction like this on the board and you see X here, it means solid. When you see G, it means gas. When you see AQ, it means aqueous. When you see L, it means liquid. Don't forget this. When you see S, it's solid. When you see G, it's gas. When you see AQ, it's aqueous. When you see L, it's liquid. Now, let's dive back to our equation. We need to balance this equation. Remember the steps of balancing chemical equation. First step is that you write out the elements. So, at both reactant side and the product side. Now, the first step here is to write out the elements here, which is iron. And iron is how many here? Iron is 1. Now, at the reactant side, we also have oxygen. And oxygen is how many here? Oxygen is 2. Now, at the product side, we have iron. Iron is how many at the product side? Iron is 2. Now, we have oxygen. Oxygen is how many at the product side? Oxygen is 3. So, you can see that oxygen is 3 here at the product side, and oxygen is 2 here at the reactant side. Remember the rules. Don't write anything or add anything at the right hand side. You rather write in front of the elements or compound. So anything we are writing to balance the left and the right hand side is in front. Now let's dive into it. Since oxygen is 2 here, oxygen is 3 here, we need to come to something that can give us the 2. Now, if you look this thing, you will see that oxygen is 2 here, oxygen is 3. So if we put 2 here, let's say we put 2 here, oxygen becomes 2 times 3, which is 6. Now, since oxygen is standing alone here, we put 3 here, oxygen becomes 3 times 2, which is 6. Are you seeing that? So this means oxygen is balanced at the reactant side and at the product side. Now look well. You will see that iron has increased from 2 to 4. 2 times 2 is 4. So iron is no longer 2 at the product side. Then let's go over to the reactant side. You will see that iron is 1. So since iron is 1, we just put 4 because 4 times 1 will give you 4. So iron becomes 4. Now this shows that iron is 4 at the reactant side, iron is 4 at the product side. Oxygen is 6 at the reactant side, oxygen is 6 at the product side. This equation is now balanced. This particular topic, balancing of chemical equation, is one of the simplest topics in chemistry. So don't let it scare you. I hope you understood everything that I've taught you today. Now let's have a recap of what we learned today. So a recap of what we learned today. We started with chemical equations. Now we started talking about the key terms in chemical equations. We looked at what a chemical reaction is And we said a chemical reaction is a process in which one or more substances are converted into new substances. An example, we gave hydrogen and oxygen coming together to form water. Then we looked at the meaning of reactants and products. And we said that elements or compounds coming to form new substances are called reactants, whereas those new substances that are formed from those reactants are called products. And then we looked at what a chemical equation is. And we said a chemical equation is a symbolic representation of a chemical reaction. Then we looked at the components of a chemical equation. We looked at the symbols, the plus, and I said it separates two elements or substances in a reactant and two elements or substances in a product. And we looked at the arrow. I said the arrow can be two ways or one way. So it's only telling you the direction of the reaction. And we looked at the physical states, the things that states the physical states of the element or the compound or the substance. So I say when it is S, it is solid. When it is L, it is liquid. When it is G, it is gas. When it is AQ, it is aqueous. Now we looked at balanced equations and unbalanced equations. And then we looked at the law of conservation of mass, which is what helps us to balance chemical equations. And I said the law of conservation of mass states that matter can neither be created nor destroyed. So that means the mass of the reactants must be equal to the mass of the product. And this also took us to balancing of chemical equations. And we saw an example from IGCSE chemistry exam. I hope you understood everything I taught today. I'll be sending you your homework in the platform. So do your homework and submit it tomorrow so I go through it before our next class. If you have any questions, you can ask me now. But if you don't have none, I will see you in our next class. Until then, take care of yourself and bye. Enjoy the rest of your day.